Howdy, folks. Before we move on to the next section, I just wanted to do a couple examples of writing down the negation of statements and writing down the contrapositive, just so that you could have a little bit more practice. I really encourage you for this video to look at the question, pause, write down the answer, and then watch me do it. Because if you do that, you're going to catch the mistakes that you're going to make, and those mistakes are going to haunt you throughout the course. So make the mistake now, then you'll catch it when you watch this, and hopefully you'll start clicking together these pieces in your head. So first of all, we're going to write down negations of statements, and you're always going to see something like, when I write down negations, some phrase like, as naturally as possible. That's to avoid just saying, it is not the case that, followed by the statement, or something like that. That's not really helpful, and it's not going to be at all useful when it comes to the things we're actually going to use this idea of negation for. So again, you want something that looks natural. It looks like a reasonable English sentence, not a really artificially constructed string of words. Also, for these questions, you are usually going to see in the questions for 2.1, you're usually going to see something like a context here. You can completely ignore this if you want. It is not really relevant to how you negate this thing. But in order to make sure that this is a specific statement, I need to say what sorts of things X and Y are. But I find it's a little trickier if I just put like X is 5 and Y is 7. It's a little harder to think about negating the statement, the difference between 5 and 7 is positive or whatever. So you're going to see a context here. And then you'll have a single sentence statement. And so the goal is to write down the negation of this. Again, pause, try it, then we'll do it together. So there are a lot of things that can go wrong even in this relatively simple statement. First, what am I really trying to write? What I'm really trying to write, in as natural a way as possible, is the statement that the difference between X and Y is positive is a false statement. Or, if you prefer, maybe you could write this as, it is not the case that the difference between X and Y is positive. So then I need to ask myself, okay, if I know the difference between X and Y isn't positive, then what is it? So then a really natural way to frame the negation of this original sentence is as the difference between X and Y is less than or equal to 0. Let me go over a few gotchas that might have come up when you were writing down the negation of this. So first, it's really tempting to think of negations as being opposites. And while the negation is a logical opposite, it really doesn't have anything to do with opposite in the sense that we usually do. So you might be inclined, when you see a word like difference, to think, aha, the opposite of a difference is a sum. And so you might be inclined to say something like, the sum of X and Y is positive. But again, you have to be super careful when thinking about negations. Negations don't have anything to do with this idea of being an opposite of something. So you're not just going to flip words unless you think carefully about exactly what flipping the words means. The same is true when you get to is positive. It's really easy to have a knee-jerk reaction that I'm supposed to change is positive to is negative. And so negative is the opposite of positive, but it is not the logical opposite of positive. In other words, it is not the negation of positive. And why is that? It's because really there's 3 kinds of numbers. There's positive numbers, there's negative numbers, okay, but in between those two, there's numbers that are 0. And so if what I tell you is that, in fact, something is not positive, it doesn't tell you it's negative. But if I tell you it's not positive, then it, in fact, tells you it is negative or 0. And so saying a number is negative or 0 is the same as saying that it is less than or equal to 0. But you could equally have said is negative or 0, and that would have also been an acceptable way of communicating the same space of numbers that this is in. Another gotcha that's easy to fall into is that in the last video we talked about how when you negate an and statement, it turns into an or statement. Namely, we wrote down this thing that we called De Morgan's laws that said that if you negate something and something, then you get not something or not something else. And so if you follow this very faithfully, you might be inclined to think that this and is going to turn into an or. But if you look closely at my answer here, you'll notice it did not change. It stayed as an and. Why is that? Well, the reason is because the word and has lots of English uses. One of those English uses is the logical and, where we combine two statements together to get a larger statement. That is, again, the sense of this and. This is a logical and. This, however, is not a logical and. It is not adjoining two statements. In fact, it is really just a piece of the phrase, the difference between x and y. And so, in fact, really, if you look at this original statement and box the difference between x and y, this is just a really complicated way to describe a particular number. And because this thing that I've boxed in gold is a particular number, I can't really do anything when I go to negate this to change this. And that's why this thing in the gold box stays exactly the same when I go to write down the negation of this statement. So really, all I did when I negated this was to identify, hey, this whole thing is one thing, I can't touch that, so all I'm negating is thing is positive, and ultimately that gives me thing is less than or equal to 0. Okay. Let me give you two more examples. Again, I would really encourage you to pause the video here, try both of these, and then once you've tried it, watch me walk through this. So, here, I can break this into pieces too. So I have an m times n is odd, and an m plus n is even. And they're joined by this word or. This really is a logical or. There's a statement on either side that we're joining by an or to create a bigger statement. And so here we really are meant to apply De Morgan's laws. Again, just as a quick reminder, if you are meant to negate P or Q, you're supposed to write down the negation of P, the negation of Q, and put an and in the middle. So the negation of m times n is odd is m times n is even. Now you might be thinking, wait a minute, Tommy, you just said that when you negate something, you don't just replace it with the opposite. And isn't even just the opposite of odd? So didn't we do exactly the same thing we said a bunch of times not to do last time? And actually, it is the case that even is the logical opposite of odd. Why is that? That's because every integer is even or odd. I'm drawing here a diagram that is meant to be evocative of the diagram I drew here if every real number is negative, 0, or positive. Okay, except there's really only two boxes. Every integer is even or odd. And so if I tell you that an integer is not odd, then the complementary space is even. So even is all that is there. Okay, and so the logical opposite of m times n is odd is m times n is even. Or becomes and. And for much the same reason, m plus n is even becomes m plus n is odd. Again, we do not have to think about the truth value of anything that's floating around here. Indeed, depending on what m and n are, it might be the case that m times n is odd or m plus n is even. Or it might not be the case that m times n is odd or m plus n is even. But one thing that you can keep in mind is always true is that of a statement and its negation, exactly one of them is always true and the other is false. So no matter what m and n I choose, one of these two is true and the other is false. Next up, we have a statement about an integer n, and this is an if-then statement that reads, if n is prime, then n plus 7 is not prime. Remember, I'm meant to be interpreting this as being about a particular n, so something like n is 11 or n is 12, something like that. And so this is an if-then statement. And I want to point out that there are a lot of different things we do with if-then statements. One, which we did in the last video, and which I'll do a couple examples of in a minute, is to write down the contrapositive. And so you might reflexively think, oh, this is an if-then statement, I'm just supposed to write down the contrapositive. But in fact, the contrapositive is logically equivalent to the original statement, and so that is, in fact, basically as far away as you can possibly get from negating the implication, which is what we're asked to do here, is to negate this implication. You might also think, oh, well, then does that mean we're supposed to write down the converse? But that's not correct either, because the converse sometimes is equivalent to the original statement, and sometimes it's opposite. So that's not going to work either. So what that means is I have to think carefully about what the negation of an implication is. And it's very helpful, in the purposes of thinking about the negation of an implication, to look back at the actual truth table definition of implication. So we have here P implies Q, which is true if both P and Q are true, is false when P is true and Q is false, and true in all the other cases. So what should the negation of this look like? The negation of this implication should be false in all of these instances, except it should be true in this instance. Let me write up a table for that real quick. So this is the thing I'm trying to find a more natural way to put down. And so it's helpful again to think, okay, I'm looking for a way to write down a statement that has only one true. And if I look through my tables, the only one where that is the case is for P and Q. So I really do want something with an and, but I can't just write P and Q, because then the true would be in the wrong line, it would be in that line. And so if you play with this for a minute, you'll figure out this is supposed to be P and not Q, which I'll let you check. Gives me false here, true here, false here, and false here. And so that exactly works out. And so then if you want, here is a new fact that we can record for ourselves. The negation of the implication P implies Q is P and not Q. Now, this might be upsetting on sort of a visceral level, because we have this beautiful, the negation of and is or, the negation of or is and, there was all this symmetry floating around, and so you might have expected that somehow by, like, throwing in negations and, like, maybe writing the implication the other direction or something, we were going to have some nice formula for the negation of P implies Q that also involved an implication. However, the negation of an implication is not itself an implication. Rather, the negation of an implication is most naturally written in this form. But I want to point out, as much as this might not be intuitive at first, if you actually think about what it being false that P implies Q tells you, in other words, what does the negation of P implies Q tell you if it's true? It tells you you're in exactly this line. So, because the only way for P implies Q to be false is for P to be true and Q to be false, the only way for the negation of P implies Q to be true is for P to be true and Q to be false. And this and statement is exactly the statement P is true and Q is false. And so, while on the one hand you might not expect this, on the other hand, this is exactly telling us the structure we agreed to for the implied arrow. It's exactly telling us, hey, if you're in this case where the negation of P implies Q is true, then you're in exactly this line where P is true and Q is false. Okay. So that is the negation of an implication. So that means when I go to write down the negation of this implication, I want to keep P, that is the if part, exactly the same. And then instead of a then and an if, I'm going to write and then I want to negate this part. And so the negation of n plus 7 is not prime is n plus 7 is prime. So when you go to negate an implication, you end up keeping the first part the same and negating the second part. If you think through this logically, this will be what you'll come up with. And you can always go back and check by writing down the appropriate truth tables. But just be sure you're carefully thinking about all these situations as they come up, because it's really easy if you go on autopilot with negating things to end up with something completely off. Since we were just talking about contrapositives, I want to do a couple more examples of writing down the contrapositive of something too. Again, pause, write down the contrapositive, then watch me do it. So remember, by definition, the contrapositive of P implies Q is not Q implies not P. And remember, the reason why we like writing down the contrapositive is that the contrapositive is logically equivalent to the original implication. And so when I said before that of a statement and its negation, exactly one is true and exactly one is false, similarly, of an implication and its contrapositive, either both are true or both are false. Always. Okay, so we need to do the flippy part first. So I need to start with the then part, and I need to negate both x and y are rational. And please, please, please do not write something like both x or y are irrational, because I don't even know what that means. So I have to think really carefully about what the negation of both x and y are rational is. And one way we can always think about this is we can always think of ourselves as sort of going through a box here, where we have on this axis x, which could be rational or irrational, and on this axis y, which could be rational or irrational. And so both x and y are rational. That would be this box. So then the logical opposite would be these three boxes. And if you take a second to think about it, these three boxes together are describing exactly x is irrational or y is irrational. Now, I'll note you can go straight there if you realize the statement both x and y are rational is just a fancy way of saying x is rational and y is rational. Namely, this both x and y blah is just a linguistic way to shortcut saying x is rational and y is rational. And once you think about it this way, then our usual De Morgan's law exactly applies. X is rational gets negated to x is irrational, y is rational gets negated to y is irrational, this and becomes an or, and we end up in exactly the same place. Whichever of those ways works for you is fine. So, if x is irrational or y is irrational, then, and now I'm supposed to write down the negation of x times y is rational, and so what am I going to get? Then x times y is irrational. Again, please note, we did something completely different in this example than we did in this example, because in this example we were asked to negate an implication, and in this example we were asked to write down the contrapositive of an implication. So here we're back to talking about integers. And so we have here, if m is square free but n is not, then m plus n is a power of 2. Take a moment to yourself, do it, and then come back and watch. So we're going to write down the negation of m plus n is a power of 2, which I don't think there's any better way to say than m plus n is not a power of 2. But now we come to what can potentially be a sticking point, which is we have this phrase, m is square free, but n is not. What does this but mean? Logically. And here's where we have to come up to realize that but is nothing but a fancy way to say and. Logically, this sentence would mean exactly the same thing if this said m is square free and n is not. So logically, but is a different way to say and. This is something that's going to come up a lot throughout this course, that there are a bunch of English ways that are very different to say exactly the same mathematical thing. And the reason for this is the same reason why there are lots of synonyms for various words in English, which is that if you go to write an essay, for example, you don't want to use the same word over and over and over again. In fact, that's probably one of the first things that you learn when you're trying to become a better writer, is that you don't want to repeat the same phrase over and over and over again. If every time a mathematician wanted to say implies, they use the word implies, reading math papers would be even more painful than it already is. So you really want to attach what you're learning in this section to the concepts of and, or, implies, etc., not to the specific words, because when you actually encounter them in the wild, they may well be different words. Okay, once we realize this is an and, then we can use De Morgan's laws to write this down. And so, namely, we will get that m is not square free, or n is square free. Final note for this. The fact that you may or may not know what the word square free means is not really relevant to this particular exercise. You could know what it means or not know what it means, and both of those are very possible, but it doesn't change that this is the answer. As such, on the homework for this section, you're going to see that you're asked to negate lots of statements that involve words you do not know, but that's okay, because, again, that's not really what this section's about. This statement is really about the raw logic. One last hint, though. On the homework, there are a few questions you're asked to answer about the words open and closed. I'll warn you in advance, and this is something that you'll see a lot in your later classes, open and closed are not logical opposites. And so when you're asked to negate open, you just have to say not open. And when you're asked to negate closed, you just have to say not closed. So again, be careful about applying too much of your linguistic intuition about math words. Mathematicians are not known for choosing the best possible words for a bunch of things. Alright, I'll wrap up this video here, and in the next video, as I promised in the last video, we'll talk about sets. But that's all for now. I'll see you next time.